In this problem, we want to find the critical numbers and the open intervals which function is increasing or decreasing. So we've got f of x is equal to x, then the square root of x plus 2. Well, we never want to leave in radical form, so this will be x times x plus 2 to the 1/2 power. It's a lot easier to find derivative if it's in that form. Now this is going to be the product rule. We got something times something else. So this will be our p and this will be our q. Now for the product rule we need p prime. Actually, let me do it over on the side. There we go. So p prime, the derivative of x is 1. Q prime. Now here we have parentheses to a power. So this is the chain rule, general power rule. If you got parentheses to a power, you take your power, put it out in front. What's inside your parentheses remains as is. Lower your power by 1, and then you multiply it times the derivative of what's inside your parentheses. So we got x plus 2. 1/2 minus 1 is negative 1/2. Derivative of x plus 2 is 1. Now we'll put this into a single fraction. 2 is already in the denominator, so I'll leave it there. The x plus 2, the negative 1/2, I'm going to put down in the denominator. And it becomes x plus 2 to the positive 1/2. And then a 1 up here. Okay. Step 1, find our derivative. The formula for the product rule is p prime q plus p q prime. So for our derivative, p prime was 1 times q, which is x plus 2 to the 1/2, plus p, which is x, times q prime, which is 1 over 2 times x plus 2 to the 1/2 power. Now, if you got a fraction of any sort, then you want to merge it all into a single fraction. So this x plus 2 to the 1/2 here, I'll put that over 1. You can always create a fraction by putting it over 1. And over here, this x, I'll go ahead and put up in the numerator, up on top. So we got x over 2 times x plus 2 to the 1/2. Now our common denominator would be multiply these two denominators together. 1 times 2x plus 2 to the 1/2 would give us 2x plus 2 to the 1/2. So that's our common denominator. So I'm going to rewrite each fraction with that new denominator. Now our second fraction already has that, so I don't have to change anything. But our first one, we multiplied the bottom part by 2x plus 2 to the 1/2, so we have to multiply the top part by 2x plus 2 to the 1/2. Now it already has an x plus 2 to the 1/2 up on top, times 2x plus 2 to the 1/2. If I were to go backwards, see how the 2's would cancel, and x plus 2 to the 1/2 would cancel, and we'd end up with this. Okay. Now the 2 just stays out in front there. X plus 2 to the 1/2 times x plus 2 to the 1/2. Since they're both x plus 2 to a power, we're going to add the exponents. 1/2 plus 1/2 gives us 2 halves, or 1. So that gives us x plus 2 to the first power. Now, since these already have the same denominator, I'll go ahead and merge them into a single fraction. So this is plus x over 2x plus 2 to the 1/2. Well, multiply the 2 through. 2 times x is 2x. 2 times 2 is 4. Plus x over 2x plus 2 to the 1/2. Which gives us 2x plus x is 3x. So we've got 3x plus 4 over 2x plus 2 to the 1/2. Okay, now we got our single fraction that we're wanting. So step 2, find our critical numbers. We're going to set top part equal to 0, so set 3x plus 4 equal to 0, and we'll set the bottom part equal to 0. 2 times x plus 2 to the 1/2 equal to 0. Now 3x plus 4 is equal to 0. Take the 4 to the right side, becomes a negative 4. Divide both sides by 3, and we get x is equal to negative 4/3. Now over here, if you have parentheses to a power or a number out in front, and you got 0 on this side, then you can drop the power, you can drop the number, and just set what's inside the parentheses equal to 0. So we got x plus 2 is equal to 0, or x is equal to negative 2. And actually, let's go ahead and plug this into our calculator. Do it that way. Here's our derivative. Now remember, if you have more than a single number or single variable on the top and bottom of your fraction, you have to put parentheses around it. So we'll need parentheses around the 3x plus 4, and we need parentheses around the bottom part. Now if you have more than a single number or a single variable in your exponent, you have to have parentheses around it. So I have to have parentheses around the 1/2. So let's go ahead and enter this in now. Okay, so I'll press y equals, press clear. We'll do beginning parentheses 3x plus 4. So beginning parentheses 3x plus 4. Closing parentheses divided by beginning parentheses, that's this one right here. Then we need 2. And then need another beginning parentheses. And x plus 2. Closing parentheses. Now we need the exponent, so that's our caret. And then we'll do a beginning parentheses 1 divided by 2. That beginning parentheses is this first blue one, 1 divided by 2. Now if you want to put the closing ones on at the end, if you can, but you don't need them. Now let's go make sure our table setup is correctly. Is set up correctly. I'll learn to speak someday. Do second window. And your independent should say ask. If it doesn't say ask, then down arrow to that line, right arrow, put your flashing cursor on ask and press enter. Mine already says ask, so I'm fine. Now we're ready to go over to the table mode. So I'll do second mode, and let's continue on with our problem. Well, we need a table of intervals. Okay. This is like -1 1/3. So as weird as it seems, the -2 is our smaller one. So I got, oops, didn't mean to do that in red. Okay. Let's try black. We got x is equal to -2, and x is equal to -4/3. You always want your smaller one over here. Build our table of intervals. Clear over here is -infinity. Clear over here is +infinity. We want to choose test cases. So I want to choose an x value between -infinity and -2, like -3. I want to choose something between -2 and -4.3. Now I know -4/3. Boy, I'm slipping. I know this is -1 1/3, -1.3. But if I just chose -1.99, I know it's in this interval and it's really close to -2. So then that's fine. You can have decimals. Over here we want to choose something greater than -4/3, like 0. Then we want to plug those into our derivative. But remember, we put our derivative over into y equals. So we can go into table mode and quickly do these. So I'll do second graph to go in table mode. I'll press delete over and over to clear out the old data I have. Then we will put a -3, enter. -1.99, enter. And 0, enter. Okay. Look at our original problem for the domain. I mentioned this in class, is that if you plug in a value and get an error, that means that that value isn't in your domain. If we come up here, if you got a radical with an even index, to find your domain, you take what's inside, and you set it greater than or equal to 0, and solve it, and you get x is greater than or equal to -2. That's where our graph exists. Down here, when I plugged in -3, see how it gives us an error? So don't think you're doing anything wrong if you plug that in. Your graph doesn't actually exist there. And if you go back and check your domain, you're going to find that that's the case. Okay. Now right here, we plugged in -1.99. It came up with a negative number, which means this is decreasing. We plugged in 0, and we came up with a positive number, which means this is increasing. So our answer, it's decreasing from -2 to -4/3, And then it's increasing from negative 4/3 to positive infinity. Now where I'm getting those numbers just across the top here, that's our intervals, -2 to negative 4/3, negative 4/3 to positive infinity. And that's our answer.